The last topic we're going to look at in our vector algebra review, before a couple of examples, is components of a vector, or projection. So let's consider two vectors, a and b, as shown below. So sort of an easy analogy for this is if we think about a light source being behind a pointing towards b. So what we have is something that looks like this. And so what we could do then is we could define a part of A that shows up on B. And so let me make it a little bit thicker. So we could see something that looks like this, which would be our component of A along B. And so what this is basically, let me draw a second line here. We could draw this down, and this would extend to where our point is, and this would be a right angle between that blue line and B. So let me come back here. And let's label this red line as A sub B. Okay, so what we can say is that this A sub B is the projection of A onto B. So A sub B is the projection of our vector A onto our vector B. So we could also say that a little differently, as I said a minute ago. We could say or let's not say or, but let's just say a different way to say this is we could say that A sub B, just saying the same thing a different way, is A sub B is the vector component of A along B. So we talked about in a previous example what was the component of A in the y direction. We said we were going to look at something a little more complicated later on. Well, this is sort of the more complicated thing. So if we wanted to look at the vector component of A along some direction of another vector that's not one of our axes, then this is what we would do. We would do projection of A onto that vector. Okay, so now we sort of know graphically what we're looking at, but how do we actually define this? Well, let's go ahead and define this angle here. So this is our theta A sub B. From that, what we can do is we can use geometry, and we can say, well, our AB, being the length of the red line, so A sub B is equal to A times cosine of that angle theta AB. So this is just from geometry. Okay, but let's try to tie this back to some of our multiplication operations that we talked about before. So we could sort of slightly rewrite this if we said AB is equal to the magnitude of A, because of course that's all we have right here. This is just the magnitude of A. And let's say that's multiplied by the magnitude of U sub B, which is our unit vector in the B direction. And of course that's true because our unit vector magnitude is always going to be 1 by definition. And then we still have our cosine of theta AB. And so again, this is because that magnitude of any unit vector is going to be equal to 1, and of course our angle theta AB is still the same. So what we can say then is that this looks really familiar to one of our previous definitions for our dot product. So we can say that AB is then defined as A dot the unit vector in the B direction. So this is a scalar quantity though, right? So this is the magnitude of this red line. So this is the magnitude of this A sub B here. So this is a scalar. So what we want to do though, if we want to find the vector component, all we have to do is multiply that by the direction that it's in, which is in our B direction. So let's say we want to get from this our vector component. So to get our vector component, we're just going to multiply by the unit vector in the B direction. So multiply by U sub B. And so what that looks like then is we have our vector A in the direction of B, or a component of A along B, is equal to AB times our unit vector in the B direction. And if we substitute this previous equation, we can write that also as just being our A sub B, our magnitude is vector A dot our unit vector in the B direction, times the unit vector in the b direction. So that's how we define our projection. So we could also use this idea to decompose A into two parts. So A can be decomposed into two orthogonal or two perpendicular parts. So two perpendicular, that's the symbol for perpendicular that we talked about before. Two orthogonal components, one of them is going to be A sub B, and then the other one we're going to call A minus A sub B. And so let's come up here and label that. So this blue line would then be our A minus A sub B. And so that's going to have a direction here. And so of course we could sort of rewrite that a little bit, and we could say that our AB, which is red, plus the blue, which is A minus AB, is equal to A. And so that's sort of a little easier way to see that in terms of our geometric addition, at least in my mind, because of course those two are going to cancel out. So being able to decompose our vectors into two orthogonal components is a very useful thing, and that's going to make a lot of our operations easier. So that covers it for our vector multiplication and various operations. I just want to note really quickly, we did not discuss vector division, and the reason we don't do that is because it's undefined, except for when our two vectors are parallel to one another. So because it's not something that's can't be generalized, it's not going to be terribly useful. In the next few videos, we're going to look at some examples, and then after that, we're going to move on to our next unit dealing with coordinate systems.